morning, students. Today we will discuss organic chemistry. Organic chemistry, the branch of the chemistry which deal with the carbon compounds. Okay, we deal with the carbon compounds. So carbon is the essential element in this organic chemistry. Okay, the organic compounds, we study organic compounds. So what are organic compounds? Organic compounds are the compounds from which the living organisms are made up of. And organic compounds are made up of the major element we talk about, that is carbon. Along with the carbon, you may have oxygen, you may have nitrogen, but the basic skeleton that you will find is of carbon. Okay. So now we will discuss the chemistry of these organic compounds. Let's first classify them. Okay. So organic compounds are generally and are also known as hydrocarbons. Because hydrocarbons, as the name suggests, carbons for this and hydro for hydrogen. Okay, so organic compounds are made up of carbon. So let's first discuss about this carbon. Okay, carbon, the atomic number of the carbon is 6. And the electronic configuration, if we talk about it, will be 2 and 4. The first shell will contain 2 electrons, the maximum it contains, because every first shell contains only 2 electrons, and then in the next we have 4, and we know to complete the octet it needs 4 more electrons. Now it needs 4 more electrons, and these means carbon can form 4 bonds. Okay, and these 4 bonds are completed by H. Not every time. When there is no other bonded atom, then every time you will complete the bond of this carbon by H. Okay, so it will be CH4. So this shows carbon is tetravalent, because carbon will form 4 bonds. Every time when you have carbon, please make its 4 bonds. Okay, if the carbon is already bonded to someone, suppose carbon is bonded to any other atom of carbon, then 1 bond is here, and then remaining 3 will be H. This carbon is also bonded to this carbon, and the remaining 3 will be by H. Okay, if the carbon is bonded like this, then 1 bond is here, then 3 bonds by carbon. 1 bond is here and 3 bonds by 2 bonds, because 1 is here, so remaining 2 will be completed by hydrogen. So what is the conclusion of that? That you have to complete 4 bonds. You have to complete the remaining bonds by hydrogen. Okay, this is the necessary thing. Okay, now these hydrocarbons, okay, you will see, I'm telling you the structure of these organic compounds. Generally you will see the skeleton like this. Okay, you will see like this also. Okay, you will see the compounds of carbon like this also. There will be a branching in the chain. Okay, so lot of organic compounds are possible. Please, students, complete it by H. Okay, so why there are so many compounds of carbon? So the one reason is the property of catenation. What is catenation? Catenation is nothing but the self-linking property of any element. Self-linkage property of any element. Here you see one carbon is bonded to other carbon. Okay, this carbon is again bonded to the other carbon, means the carbon has the capability to bond with the other atoms of the carbon. That's why a lot of organic compounds are possible. So this is the reason. So catenation is the reason that there are a lot of organic compounds are possible. Catenation is the reason that there are lot many compounds of not many compounds of carbon, that is hydrocarbons, organic compounds, are possible. Okay, got it? Okay, so this is the reason. So basically we have discussed that a carbon has 4 bonds, that's why it is tetravalent, and carbon atom has the property of catenation. So these things you must keep in your mind while doing the organic chemistry. Every time when you make the carbon, please see its 4 bond must be completed, otherwise your question get wrong. If this catenation is the reason there are lot many organic compounds. Okay, now classification of these hydrocarbons. So generally the broadly classified, if we talk, then first is aliphatic, okay, and then the second class is cyclic. Aliphatic means open chain hydrocarbon. There is no chain formation or ring formation. Open chain hydrocarbon. Okay. Just a minute. Yes. So open chain hydrocarbon, and this is closed chain hydrocarbon. I have drawn these figures in earlier slide also. So what are open chain? As the name suggests, there is no ring formation. Like this is open chain. Okay. If the branching occurs, no need to worry. This is open chain. It is not closed. What is closed? Closed means like this. Like this first carbon is bonded to second carbon also, third carbon also. But here the first carbon is bonded to only second carbon. So this first is bonded to third and second. That's why a ring formation. Ring may be 4-membered ring. This is 3-membered ring. Okay. Ring may be 5-membered ring. So like this, these are 5 carbons and we have bonded it to 1 2 3 4 5. Okay, so you have aliphatic, you have cyclic. Now let's discuss aliphatic. Again they are classified in alkanes according like first is alkanes, then we have alkenes, and then we have alkynes. Okay, now alkanes, what are alkanes? So the thing that you need to keep in your mind while doing the alkanes, that the carbon-carbon bond. I told you in this slide also, there are lot many carbon-carbon compounds. In alkanes, what will happen? The carbon-carbon compound, carbon-to-carbon bond will be single covalent bond. Every bond is a single covalent bond. Then alkenes, carbon to carbon double bond. But one thing, at least one bond must be a double bond. अब मैं ये नहीं कह रहा कि that all the carbon-carbon bonds must be double. No, it's not possible. So like this is double bond, okay, and then this double bond may exist like this also. So the position of the double bond varies, but at least one of the bond between carbon-carbon must be double. That's why you will fall these compounds into alkenes. Now alkynes, the carbon-carbon triple bond. You will see at least one carbon-carbon triple bond like this. This is one, Okay, you can make the figure this. Suppose here there is a triple bond, so at least one must be triple bond for the alkynes. Okay, now if we talk about alkanes, the alkanes, this is a general formula of the compounds containing carbon-carbon single bond. Okay, so let's start first member. Suppose first member contain only one carbon. Okay, second member will contain two carbons. Third member will contain three carbons. Fourth member will contain four carbons. Okay, and then complete the bond using hydrogen. Because I told you, you cannot leave this carbon alone. You must complete the bonds, 4 bonds. Okay, every time 4 bonds, never 5, never 3, never 2, only 4 bonds of the carbon. If you're not drawing the 4 bonds, means you are disrespecting this carbon, and that's this, because of this disrespect of this, the major element of the organic compound, you will get 0 marks. Okay, and this is known as methane, the first member. This is ethane. This is propane. We have discussed this in the IUPAC naming. And this is butane. The word root but, prop, eth suggests the number of the carbon atoms. Meth for 1 carbon, eth for 2 carbons, 3 prop for 3 carbons, and but for 4 carbons. And ane suggests the single bond. Ane suggests the single bond. Okay. Now just observe, observe that the difference of the elements in this first member and the second member. You will see in first member, that is methane, we have 1 carbon. In ethane we have 2 carbons. So the difference is of 1 carbon. Then in methane we have 4 hydrogens, and here we have 6 hydrogens. So difference is of 2 hydrogens. Now compare this ethane and propane. In ethane you have 2 hydrocarbons, and in propane you have 3 carbons, means the difference is of 1 carbon. Now count the hydrogens. In ethane there are 6, 1 2 3 4 5 6, and in propane we have 1 2 3 4 5 6 7 8. So 8 minus 6 is 2. Again the difference of hydrogen is 2. Then in propane butane you will see here 3, here 4, the difference is of 1 carbon, and then when you will calculate these hydrogens, then you will find it is also CH2. So this is the beauty, and we call this series in which we have a difference of CH2 in all the members, that is known as homologous series. So each member is differed by CH2 unit. Okay, suppose now if I want to get the 5th member, you know the butane C4H10, this is butane. If you want to know what is the 5th member, just add CH2 and you will get C5H12. Again, if you want to know the 6th member, just add CH2, and this is known as C6H12. So this is known as the homologous series of alkane. Similarly, the same thing will happen in alkenes also, and same thing will happen in alkynes also. Now we will discuss the properties, the preparation of the first member, that is methane, in the next class. Thank you so much.